All right, math people, we're on 10.4, volume of spheres now. We've already talked about surface area. Now we're going to talk about volumes. I will give you the heads up that, in my opinion, surface areas are much more difficult. You have to think about a lot more. You have to kind of make up your own formulas. Whereas in this one, we're going to be using formulas. So what's the success criteria? The success criteria is to use a formula to find volume, and in the second, it is to use the formula for the volume of prism to find a missing dimension. In other words, solve an equation, right? Okay, so what is volume compared to surface area? Well, surface area, remember, was if these were presents, we had to wrap with wrapping paper. The amount of paper we use to around the outside is surface area, whereas volume is if we were to fill them full of some sort of liquid or, since they're presents, we may need to put those little styrofoam thingies in there. But it's filling them all the way up to the top. So it's everything that goes inside of it, okay? So all right, so that being said, what makes a prism a prism? And remember, a prism has two bases, and it is named after whatever shape the base is. So in this particular case, my bases are 1, 2, and those two bases are rectangular, so it is a rectangular prism. Here we have triangles, so it is a triangular prism. Here we have pentagons, so it is a pentagonal prism. Here we have hexagons, so it is a hexagonal prism. Okay, so that's what we name them. Remember, there's two of them. But to be honest, in volume, we don't care about how many, because what we care about is we only care about one of them. And the reason we care about it is, if we just look at this rectangular prism, is if I know how much area this bottom part is made up of, okay? So I know how big of the base is. Then what I care about is, well, how high it is, right? Because the amount of water is going to fill the bottom, and then it's going to start filling upward, right? If I'm pouring water up here into the top. So I'm going to keep filling, and I'm going to keep filling, and I'm going to keep filling until it's full. So what I care about is, like I said, the area of the bottom is going to make a difference, because I have to fill the bottom first. And then my height is going to matter, because, if I moved my height up here and made a new shape, right? Oh, this is going to be bad, but we're going to deal with it. All right, if I made a new shape, then because the height is higher, I have to keep filling further once I get up to this area. So the height matters when you're talking about volume. So that's what you're going to notice. All right, so let's move on to the slide. Okay, so what are they telling us here? The volume of three-dimensional figure is the amount of space that it occupies. So how much, that's the fancy way of saying how much can I pour into it. Volume is measured, notice, in cubic units. So we talked about this a couple times. So inches cubed, meters cubed, yards cubed, all that, okay? So you're always going to, for science cases, you'll need to remember that specifically. In Big Ideas Math, they're actually going to label it for you, but just keep that in mind. Okay, so here's what we need. I talked about this, and I've already started, but this area of the base, this big B, okay? Little b means the base of a triangle, for instance, right? So little b is just this line. Big B means the area of the base. Oh, they already wrote that. It means the area of the base, okay? So we need to substitute in for that B. We need to substitute in the formula for the area of that specific base. So, for instance, when we look at this, well, this base is just length times width, right? Whereas a triangular prism has a 1/2 base times height is the area of a triangle. So we would use that in place of big B. All right, so keep that in mind as we move on. Let's do a couple. All right, so let's look here. Okay, so find the volume of this prism over here. This is a rectangular prism. therefore, our big B here is length times width, or base times height. You'll find that those come up kind of, it just depends on how you think about it. So volume equals length times width times height, right? So really this is just length times width times height, because here's my height, here's my length, we'll say, here's my width. Okay, so we're just going to say volume is equal to 8 times 6 times 15, and then we'll get our calculators out and we will put in 8 times 6 times 15, and we get 720 yards cubed. All right, that was easy. See, this one's easier. Oop, I added one. Let's move on. Okay, so in this one we have a triangular prism. So we have to worry about this big B is going to be 1/2 base times height, right? So volume is going to be 1/2 base times height of the triangles times the height of the height again, I guess. So let's plug some things in. So this is the base of my triangle. This is my height, and no, actually, and then this will be the height of, yes, sorry guys. So this will be the height of the prism, because our bases are these triangles, okay? So let's keep that in mind. Okay, so 1/2 the base, 5.5 of the triangle, times the height of the triangle, which is 2, times the height of the whole thing. And I know that 4 looks really weird as a height. It even threw me off for a second, just because it looks like it's not a height. But if you would look at this upside, or flipping this thing on its face with the triangle as the bottom, try not to think of base always as bottom, okay? All right, so volume equals 1/2. Well, 1/2 of 2 is 1. 1 times 5.5 is 5.5. So 5.5 times 4 is 22. So volume equals 22 inches. You said it, cubed. I know you were all over that. All right, so now we get to the modeling real life problem. So each bag of popcorn shown over here holds exactly 96 cubic inches of popcorn. Note, cubic inches. That means volume equals 96, okay? So which bag should a movie theater choose in order to use less paper? Okay, so hopefully you are saying to yourself, Mr. Hines, you told me that wrapping the paper was surface area, and you would be correct. This is actually a surface area problem, but to begin with, in order to find surface area, right, I need to know what this missing H is. So what I'm going to do is I'm going to use volume equals base times big B times height, and I'm going to solve for H, and then I'm going to use that to solve for surface area. Okay, so let's make this a little smaller. I'm going to run out of space here. So volume equals big B times the height, so therefore volume equals length times width, which is since these are rectangular prisms, or actually this one's a square prism, but either way. So length times width times the height of the bag, okay? So volume equals, let's look at bag A. So let's actually separate these really quick. So bag, you like my song? Bag, let's change colors. I've got a new software and I love it, but I'm still getting used to where my buttons are. Bag A, bag B. Bag A is volume equals length times width times height. Bag B is going to be the same. Volume equals length times width times height. So let's plug in some numbers. Volume is 96. Okay, we already know that right there. Boom. They told us that in the equation. The length times width over here in bag A is length is 4 times width is 3, which equals 12. And then, so let's actually, just to save some space, I'm really afraid I'm running out of space here and have to do this over again. So this will be 12 times h, or 12h. So we're just going to divide both sides by 12. And we're going to have h is equal to, what is that, 8? Yeah, 8. And then we have bag B, so the height of one is A. Okay, so volume equals, let's do this one in our head. So length times width of this one, or squared, since it's squared, 4 squared is 16. 16 times h. Oh, and I forgot to put my volume in here, which is 96. Okay, so 96 divided by 16 should be 6. Yep, 6. So there you go. So now we've got our bag A, bag B heights. Okay, so now let's do surface area. Okay, let's do it over here. So these are our surface areas over here. We have bag A. That looks like bug A, bag B. Man, I'm writing terribly today. Okay, so now we have to think. So what is the surface area? Well, the surface area is going to be the surface area minus, normally we would do, since it has 2 bases, we would multiply that base times the times 2, but in this case we don't need the top here, right? The top does not have paper, so therefore it'll just be 1 base. So we'll call that the B for base. So B is equal to length times width, which is 12, and we don't need any more. So now let's talk about this front part. There are 2 of these front parts. Okay, so we needed this h, which is why we solved for it. So this one's 8 and this one's 6. So this part right here is 8. 8 times the width here is 4. That'd be plus 32. Only that's times 2, because there's a front and a back. So front, here I should, I'm trying to save space here, guys. Front and the back, which would be 64, so we have 12. So just to be fair with this, okay, for those, they're not even going to let me erase. That's funny. Okay, so we're just going to call this surface area. So now we're official. And this is the base, this is the front and the back. So we've done that, and now we just need our sides, right? So our sides are this width and this length. So it's 8 times 8 is our height, right? This thing right here corresponds to that side, so it's 8 times 3. Okay, so we have plus 64 plus 24, but that's 24 times 2, because there's 2 of them. So that would be, where am I at, 24, which would be 48. So I do my math, 24 plus 64 would be 124 square inches. Okay, screenshot that if you want, guys, because I'm going to have to erase part of it. Or actually, you know what? I think we can make this work. Let's just do one of these little lines. You guys do that. I know you do it. Okay. So the surface area of B is going to actually be even simpler, okay, because it's got some squares. Okay. So the surface area is equal to, well, it is length times width. So the base is 16, and there's only one of those. We've got a front and back on this one, and we've also got sides. Okay, so front and back is going to be this, which is 6. 6 times 4 is 24. 24 times 2, because there's a front and a back, is 48. And then the sides are going to be, well, it's got a height here of 6. 6 times 4 again, which is 24, which is another 48, because there's 2 sides. So we had 16 plus 48 plus 48, and we get 112, and that was what we wanted. So this is 112 inches, and I made a huge mistake and forgot to put, these are squared though, because remember, surface area versus volume. All right, hopefully that helps. Take care, guys. Bye-bye.